Woohoo! Oh, dude, this is awesome. This is going to be our skater that we're going to use to investigate motion in 2 dimensions. So, here, I'm just going to pause him. And I'm going to put him up there, and then, oh, I'm going to drop him, and ooh, he's indestructible. Okay. We unfortunately don't want this very stylized ramp. What we're going to do is make it into a straight ramp. And we right click on points and delete the control points, and now we have a nice straight ramp that we can run our skater down. Now, in order to measure my angle, I'm going to have to use a bit of trigonometry, so I'm going to turn on the measuring tape, and I will measure the length of the opposite side, 3.55 meters, and the length of the hypotenuse, 7.62 meters. And now I can use SOHCAHTOA and the inverse sine to figure out what the angle of my ramp is. In order to follow the skater, we click the Show Path button, and you'll see in just a second when we let him go that we can follow his motion with little dots, and those little dots are going to be kind of instructive. Now, I have paused this while we've been doing this just to make sure that the skater doesn't take off on us. So I have Show Path on, I have my angle measured, that's going to be my independent variable, and now I'm just going to click play, and my skater takes off, and I'm going to hit pause so that he doesn't run away on me. Now these dots are super convenient. They do a lot of things for us. If you click on them, you can actually get the speed that the skater has traveled on a particular dot. Okay? Ignore everything else and choose a different dot. So I picked that dot right there. Oops. You can erase them by clicking on them again. So I'm going to pick this dot right here where I think he started, and I see he has a speed of 1.66 meters per second. I'm going to make that go away. Now I'm going to click on the dot down here. Actually, I'm going to click on this dot. No, I'm going to click on, no. I'm going to click on this dot right here, and I can see that he has a speed of 5.55 meters per second. So I have 2 speeds, and I'm now going to measure the distance between the 2 dots that I just measured. So that one to that one, 4.5 meters. So there, I've got 2 different speeds and the distance between them. What I'm going to be figuring out is the acceleration from those 2 calculations. Now, so here's how I make my calculation using some of our good old kinematics equations. I've got my 2 points, I've measured the speed at the 2 locations, and I've used my tape measure to get the distance between the 2 points. So I can pretty well those things, my distance and my 2 speeds. Okay, so I'm going to use this kinematics equation. The second velocity squared is equal to the first velocity squared plus 2 times the acceleration times the distance, because I can tell those are my givens. Okay, so all I need to do is rearrange this equation a little bit, and Bob is going to be my uncle. So I really just need to isolate A, so I'm going to move this one over a little bit, and what I'm going to do is I am going to subtract the 1 here from both sides. There we are. And now I have 2AD, and what I'm really trying to do is isolate A, so I can divide by 2D, and that is how I'm going to calculate my acceleration. I'm going to be choosing several angles, so I'm going to change my ramp. I'm going to remeasure the distance, the opposite side, and the hypotenuse, and I'm going to calculate my angle based on the hypotenuse and opposite side, and then I'm going to drop my skater. Oh, I'm going to have to show the path. I'm going to drop my skater again, and I'm going to be measuring 2 speeds in 2 locations, and I'm going to be measuring the distance between those 2 dots. So it does get a little bit tricky with these little numbers, but it's not unmanageable. Now I have some mocked up data here, and I've put it in a spreadsheet, but basically what I'm trying to demonstrate is that you're going to be measuring the angle of the ramp, and you're going to be calculating the acceleration in meters per second squared. I'm using degrees here to measure the angle of the ramp, and that's going to be based on my calculation of the angle using SOHCAHTOA. When I have my data, I do want to graph it, and I do like to graph it in a program that I can actually fit a curve to it. We're going to be doing curve fitting for the first little while rather than curve straightening. So in Geometer Sketchpad, I'm going to plot this. I'm going to go plot points, and I'm going to just enter what the points were. So if I had 10 degrees and 1 meter per second squared in acceleration, I hit plot, and there's my point. Now if I had 21 degrees and I had 2.3 meters per second acceleration, I hit plot again, and I will have plotted another point. In Geometer Sketchpad, it's usually a good idea to keep the rectangular grid form, and then after you get your points plotted, you can change your grid so that you can get something that makes sense. When you're done, what I would like you to do is try and fit a curve to these points that you get. And I'd like you to try and figure out what function best fits the data that you get. So you'll go graph, plot new function, and you have all kinds of choices here. For example, you could go sine of x and hit OK. Do you want to use degrees or radians? Yes, I'll use radians in this case. I think maybe I better switch to degrees though. So there, I've switched to degrees. Okay. And I can edit my function fairly rapidly. I can put 6 times, and I can change my function that way. All right. That should give you a little bit of a start, and I want you to try and work on that as independently as you can.